Hey everyone, I hope you all are safe and doing good. So, in this lecture, we will see what is polymorphism in Java. Although we have discussed polymorphism, like whatever we have discussed till now, method overriding, overloading, dynamic method dispatch, all these things are like comes under polymorphism only. But specifically, I just want to upload a lecture on polymorphism. Whatever we have discussed, that we have already discussed, but let's just make it in a single lecture so that you get it better. Okay. So, as the name suggests, see polymorphism. So you will get this thing, I mean, almost in every book and on the internet also. Like the meaning of this method, this is a Greek word. So it's like made from two words, poly plus morph. Poly means many, and it means form or behavior. Form or behavior, you can say. Many forms or many behavior. Like I'm also having a polymorphic behavior. I'm a single person, but whenever I'm with my family, my behavior is different. Whenever I'm in a class, my behavior is different. If I'm with my friends, my behavior is different at that time. So the person is same, like Jenny is one person only, but my behavior depends on the situation where I am. Okay, like my family call me like I'm a daughter, or for someone I'm a sister, I'm a wife, I'm a mother, something like this. So my behavior is different. In my like classroom, they call me like teacher or ma'am. My behavior is different. With my friends, they call me with my nickname or any other name, some funny name. So the behavior is different. So they can identify me with different names, but the person is same only. Yes, name can be different, like Jayanti, Jenny, or any other name, but person is same. And the behavior is also depends on where I am on the situation. So I'm having many forms or many behavior. Same thing happens with like objects or methods also. If you think of this thing about in the terms of object oriented programming, or in this case, then we can say polymorphism allows objects for of different classes to be treated as objects of common superclass. I hope now this line is making you some sense because we have discussed this thing many times. Objects of different classes to be treated as objects of common superclass. In the previous case, you can take the superclass was shape, and subclasses was three subclasses: circle, square, rectangle, or circle, square, and like this. So the objects of these subclasses can be treated as objects of the superclass as well. Yes, because circle is a shape also. So this object can be treated as a object of superclass as well. So like we can identify that object with different names or different types. So that is like polymorphism. Or in case of methods, if I say, then the one method or one action can be performed in different ways. So this thing you will get it better when we're discussing types of polymorphism. Okay, let's see now. Next, that thing we are having. Same real life example we have taken in the previous case also, smartphone and remote control also. Polymorphic behavior, these buttons are having polymorphic behavior. If this button is now, these remote is binded with my camera and this. So if I press one, the screen is, or the control, or the camera will set to this whole screen. If I press two, this camera would focus on my chair only. Okay, if I press three, then maybe the camera would focus on the a larger area. So I have binded these things. If this kind of remote is at your home for your TV, then if you press one, there would be like some channel would be changed. For two, there is some other channel. So the remote is same or the buttons are same, but behavior is different. It depends on the situation with which this remote is binded. Okay, same with our phone also. So these are like polymorphic behavior. According to the situation, behavior changes. Fine. Okay. Now, types of polymorphism. There are basically two types of polymorphism, and this is one of the core principle of OOP, object oriented programming. This is very important. Two types of polymorphism are there: compile time polymorphism and runtime polymorphism. And these two types we have already discussed. Compile time polymorphism we can achieve with method overloading. We have discussed method overloading in detailed manner. What is method overloading? So that is nothing but compile time polymorphism or static polymorphism. Runtime polymorphism can be achieved with method overloading. Sorry, method overriding. Method overriding also, dynamic method dispatch we have already discussed. So that is nothing but runtime polymorphism or dynamic polymorphism. There are two types of polymorphism. Got it? Compile time, see, known as static polymorphism, and it is achieved through method overloading. You know very well what is method overloading. Method overloading can be within a same class. Usually it's within a same class. We are having two or more methods with same name but different parameters. That is method overloading. So if I am having a single class here, these are method overloading. See, we are three methods we are having. Name is same, parameters are different. Although the number of parameters are same, but data type C. Int, but here we have int and float. Here we have a float and int. Order is different. In the previous case, int float. In the second case, float int. The order is different. So this is method overloading. Or you can have like there are two parameters, then we can have int a, int b, int c, three parameters. That method is also overloaded method. So method name must be same, parameter must be different. This return type may or may not be different. If we are having this method, like one more method I'm having void, sorry, it's not void. Suppose I'm taking here int and add int a comma int b. That is not method overloading. Method signature is same, only the data type, only the return type cannot differentiate these two methods. So it will give you error. It's not method overloading. Method signature must be different. Method name must be same, but parameters must be different. Okay. So this is nothing but compile time polymorphism. Why it is known as compile time polymorphism? Because which method is going to be executed, that is being decided at compile time only by the compiler. Yes, at the compile time when you are going to create object of this demo class, and when you call d dot, suppose object is d dot add, we are passing 1 2. Which method is going to be called? That actually that method has been binded at the compile time only by the compiler, decided by the compiler only. So that's why it is known as compile time polymorphism, and based on the number of parameter and the type of parameter to be passed. So exactly, first it will check exactly matching method. Exactly matching method is, yeah, int a, int b, int. So it will call this method. It's binded at the compile time only, at and run time only this method would be called. So that's why it is known as compile time binding, compile time polymorphism or static polymorphism. Got it? Okay. Now, see, the compiler determines which method to call based on the method signature, whatever the method signature. But here, early binding is done. I have discussed static binding or early binding, we can say at compile time only it is being done. Method signature, so it differs in number or the type or order of parameter. For method overloading, method signature must be different. Faster execution as the binding occurs early. At the compile time only decided which method is to be done, so little bit faster. This is changing only the return type does not means that the method is overloaded. No, that thing I have told you. Runtime polymorphism is what? It's achieved by method overriding. At runtime, it is being decided actually which method is going to be called, which version of the method. Method signature binding is done at compile time only, both for instance method and static method. But method implementation binding is done at runtime. Which version of the method is going to be called actually being decided at the runtime based on the object type. That's why it is known as runtime polymorphism. Got it? And we have discussed these things, and the it is being decided by the JVM, not by the compiler. See, the resolution is done by JVM. Static or compile time polymorphism is done by compiler. Means at that time compiler decide which method is going to be invoked. Here JVM decide. Okay. And this basically occurs in inheritance. There is a superclass, there is a subclass, and method is overridden method. Then runtime polymorphism is done, or it is also known as dynamic method dispatch. We have seen a complete video on dynamic method dispatch. Okay, previously. So I think you are clear with this topic. This is just a simple example of runtime polymorphism also. Now, see, late binding is done here, or it is also known as dynamic polymorphism, or you can say it's dynamic binding is to be done at runtime binding is done. Method signature in this case must be exactly same. Both the method name as well as the parameters must be same for method overriding. Only, see, maybe must be exactly same in the superclass and the subclass. Access specifier can be different, but access specifier cannot be less restrictive. Sorry, we can say like it cannot be more restrictive. If in superclass the method is public, so it can be public only in subclass. It cannot be more restrictive, like make it protected or default. No. Okay. Now, okay, it allows for more dynamic and flexible code. This I have told you with dynamic method dispatch how flexibility and extensibility we can achieve at runtime polymorphism. So code reusability would be there, and then flexibility is also there. This thing we have discussed in the previous lecture. Interface based programming enables programming to interfaces. Like interfaces we haven't discussed yet, so let's leave it. We discuss interfaces also in the later videos. Okay. Now, same thing here also having one scenario, just drawing an application with various shapes. With the draw method, we are having different shapes are there. So this thing we have already discussed in the previous example, in the previous lecture. This example. Got it? Now, sometimes you confuse between overriding and overloading, so that can be a problem. Static method cannot be overridden method, cannot be overridden is not possible for static method. Using a more restrictive specifier in the overriding method, that can also be a problem. So you need to take care of these things. Final methods, if you're trying to override a final method, that also will give you some error. So you have to take care of these points in polymorphism. Okay. Now, with the help of an example, let me just show you what is compile time polymorphism and runtime polymorphism. So method overloading in the same class we have already discussed. I hope you remember that lecture. See, there we have discussed the class was method overloading, and we have discussed we can overload static method as well, like print int a double b string str. We can overload instance method as well. And there one example was type promotion also. Okay. So this was like within the same class we are achieving method overloading. So I guess we don't have to repeat this same lecture again. It's like wastage of time. You can just go and watch this lecture. But let's try out method overloading in different class. Method overloading we can achieve within the same class as well as in inheritance also, in superclass and subclass. So if I am having, suppose this is my, let's take this example only, person. Person is a class, that is superclass. And here we are having one more class, student. Student was a subclass. Because in person, let's take, we are having a method, suppose greet, void greet, and this hi, we are printing hi. Let's pass here string name. Okay. Now just overload this method in student class. So in student class, I'm having one more method. Do we have greet method? No. So let's make a method here, greet. So I'm having this greet method in student class. I'm passing here name as well as roll number. So the method signature is different. Number of parameters are different. In the person, we were having one parameter. Here we are having two parameters. So by default, obviously the student is inheriting person class. So this greet method is also a part of student class. And one second method we are having this. So this is like method overloading. Okay, now let's go to the main class. Where is the main class? Now we have created person, new student. Student is this, and we are calling person dot greet. So here obviously you have to pass expected one argument but found zero. So it is going to bind this greet with person at the runtime. Like method signature binding is done. So it is checking in the person in the reference type. Do we have a compatible greet method? Yes, we have in person. So it is just you know expecting us to give only name. So in main, let's give it Jenny. See, whenever I call, see, let me show you person dot. See, greet string name. Only one method is shown. Only one greet method that is having only accepting only one parameter, not the second one. Because actual object haven't been created at compile time. So it will show only one greet method. Because the reference type is person is of type this person class. So whatever is there in person class, that method is to be shown. But if I change it something like this, so okay, let me just run this first and show you the output. If I run this, then it will show hi, simple. Or in person class, let's just name it hi and plus whatever the name it will print. We have modified it a little bit. Let's run this, so it will print now hi Jenny. But it is not going to call the method from overloaded method in the like in this method name and roll number. No, if you want to call this, then here you need to create an object of student class. Now the person is not there. S. Now rather than writing this, if I try to write this thing like s dot c s dot, we are having this method name and int roll number. But I just pass here only one like file. That's it. S dot greet and file. Let's run this and see. Do you get any error? No, it will simply print hi pile because this greet method is in the person class and student is inheriting person class. So it means it is part of student class as well. Okay. So you can call this or rather than that again if you call this like two method we are calling. So these are overloaded methods in different like inheritance. First high pile, then stand up Jenny roll number 22. This method is going to be called the second one. This one. Okay. But simply if you think that let's change it here. Method signature must be same. But let's change this to something different. Let's change this to string. It will give error. See, it clashes with greet in the com in this person class attempting to use incompatible return type. So only return type if you change, then it will give you error. It's not method overriding and it's neither method overriding nor method overloading. So this thing you need to take care. So let's make it void only and here you can change it. So this is like method overloading in different classes like in super class and subclass in inheritance. So usually but we do method overloading within the same class. And method overriding I have already shown you. In person class we are having this display. In student class also we are having display. But the signature is same, method signature is same, but implementation is different. So that we can simply call here with dynamic method dispatch as well with the help of person class only. So I think method overriding we have discussed many times, so no need to show this thing again and again. And you know what this is called? We are having let's the reference this reference variable. This is reference variable of this parent class or the super class. And if I write something like this, now person is equal to new student. So the object is of child class. Reference is of type parent class, object is of type child class. So this is basically known as upcasting. The reference variable of parent class refers to an object of child class, and this is known as upcasting. And in the previous dynamic method dispatch, in this case, I have shown you one thing. Let me show you that again. See, in the previous case, when we were discussing dynamic method dispatch, person was a class and the student is what? Inheriting person class. But in student class, we are having a method study, which is not in person class. Person class is a super class. But study method is not there. Got it? And when you are going to create, let's go to this main. Sorry, this is the main class for this thing. You are creating reference of this. Then you are creating new student of this. And if you go and if you want to access study method, then see there is no study method, because which I've told you this will give you error. This reference type decide access to methods, and in person there is no study method, so it will give you error. But one thing, you can typecast this, means right now you can make it of class student, sorry, student, and then the name is of the reference type name is person. Just have to put this in this bracket. So this is what typecasting. We have done typecasting of this person. Now this person reference variable is of type student class. It will not give you any error now. It will easily call study. So if you run this, it will call study method. So like you can here do typecasting. I'm studying as I have my exam tomorrow. So this is study method in student class. Okay. What do you think? If I just let me just show you that bytecode. Student class is this and main class is this. So let's see the bytecode using Java disassembler. Set the path, then just compile in that package all the files dot star dot c, it's not c, it's Java, and use Java P hyphen v, and then what was the name of that file? It was main dot class, I guess. So in main we are having C, invoke virtual, this method index number is 16, this is method in this package, and see the class name is student dot, the method name is study, there is no parameter here, and v means void type. So binding is done, method signature binding, but with the help, binding is done with student class only, because we have typecasted this to student. So at compile time only we know that the reference type is not person, reference type is also student. Okay, we have converted this. So binding is done with student class only. Okay, at compile time. So I hope now you have the idea about compile time polymorphism and runtime polymorphism. There are some common pitfalls in polymorphism. This thing we have discussed many times. This is nothing new. Now, when you are going to use polymorphism, then what you need to do? Design for inheritance. Create classes and methods with extension in mind. This thing I have told you in previous lecture also. Whenever you are going to create classes, whenever you are working on a project, just keep in your mind that maybe in future you need to extend that thing. So by keeping that thing in mind, design your classes. Use inheritance in that way. Design method in that way. Use interfaces. Prefer interface based polymorphism for maximum flexibility. Interfaces we haven't discussed yet, but we'll discuss, don't worry, in later videos. Document, okay, clearly document everything whatever you are writing, so that if you study your code later after few days or someone else study your code, then he or she can come to know that by looking at the document, okay, this method is doing what. So please document properly all the behavior of the methods. Okay. So polymorphism is nothing. I hope you got this. Only the two types of polymorphism, and there we have discussed compile time, runtime. Compile time achieved by method overloading, runtime achieved by method overriding. That's it. And these things we have discussed already. Okay. And this is one of the core concept or to the core pillar of OOP, polymorphism. You got it? Now that's it about polymorphism. I guess in the next video we'll see abstract classes and abstraction. Okay, so now I'll see you in the next lecture. Till then, bye. Take care.